Hello, this is Dr. Hanaa Assil, and this is about organic nitrogen compounds, amines, amides, amino acids, and proteins. So let's talk about organic nitrogen compounds. These include amines, which are actually derivatives of ammonia. So I can have an alkyl amine like butyl amine, or an aromatic amine like phenyl amine. Also, we have amides. Amides are the ones that have an amide linkage, a C double bond O, NH2. So that's an amide. Again, you can have an alkyl amide like butanamide or an aromatic amide like benzamide. I can also have amino acids, and amino acids are actually the building blocks for proteins, and they are made up of both an amino group and a carboxyl group. So basic amino acids like alanine or glycine, so these are amino acids. Now let's start with amines. What are amines? We said amines are organic compounds containing nitrogen atoms. So they are substituents of ammonia. So if I have ammonia, ammonia is supposed to be N with 3 H's. But if I remove one H and put an alkyl group like methyl, then this is called methylamine. If I have 2 of the hydrogens removed, this is a dimethylamine. If I have all the 3 hydrogens of ammonia replaced with alkyl groups, something like trimethylamine. So examples of amines, you can have butylamine, where one of the hydrogens is replaced by a butyl group, or methylamine, or phenylamine, which is an aromatic amine. So let's take a look at these types of amines. We can put all of these amines into 3 types. So one type is called the primary amines. What are primary amines? It's when I have the ammonia, one of the hydrogens is replaced by another group, alkyl or aromatic phenyl group. So if we replace one of the hydrogens of ammonia with one other group, that is called a primary amine. If I replace 2 of the hydrogens with different alkyl or phenyl groups, then this is a secondary amine. If I replace all 3 hydrogens with alkyl groups or phenyl groups, then this is a tertiary amine. In general, amines are miscible with water, so they dissolve in water. And if we say, why is it that amines dissolve in water? It is because they're able to form hydrogen bonds with water. Remember that the nitrogen in the amine has a lone pair of electrons, so it can form hydrogen bonds with water either between the nitrogen and the hydrogens of the water, or between the hydrogen next to the nitrogen with the oxygen of the water. So you should know that amines dissolve in water due to the formation of hydrogen bonds. And remember that hydrogen bonds are linear with a bond angle of 180. So this is how you should draw. Okay, when we dissolve the amine in water, the resulting solution is alkaline. This is because the lone pair of electrons on the nitrogen will accept a proton from the water, and this leaves hydroxide ions in the solution, which makes it alkaline. So let's take a look at one of these questions. Hydrogen bonds are formed when methylamine dissolves in water. Which structure best represents a hydrogen bond between methylamine and water? So, which one do you think is correct? Well, A, it forms hydrogen bond due to the lone pair of electrons, but remember that we said the hydrogen bond has to be linear. So this is not 180, so A is wrong. So actually, your correct answer is B. Of course, C is wrong because the oxygen is making a bond with a hydrogen that is not attached to an electronegative element. Remember that the hydrogen used for hydrogen bonding with water should be attached to an electronegative element like nitrogen, but C and D are wrong. Okay, which one is more basic? Remember, ammonia and amines are bases because of the lone pair of electrons on the nitrogen atom. The nitrogen atom can donate its lone pair to an H plus ion, and this forms a dative bond which forms the ammonium ion. So for example, I can have butyl amine. We're saying it's a base, so it can react with acids. So if it reacts with an acid like hydrochloric acid, it forms what we call butyl ammonium chloride. Now, which one is more basic depends on the availability of the lone pair of electrons on the nitrogen atom to bond with an H plus ion. So we are saying that an alkyl amine like ethyl amine or butyl amine, that is a stronger base than ammonia, and ammonia is a stronger base than something aromatic like phenylamine. So let us explain why. Ethylamine first is a stronger base than ammonia. Why is that? Remember that the ethyl group, the CH3CH2, ethyl groups are what we call electron donating. So they release electrons to the nitrogen atom. This makes the lone pair more readily available to the bond with H plus ions. So this means that it is more basic than ammonia. Again, ethyl groups are electron donating. Electron donating means it gives electrons to the nitrogen. That makes the lone pair of electrons on the nitrogen more available for dative bonding. Now, if we're comparing ammonia with phenylamine, we're going to say that ammonia is a stronger base than phenylamine. Remember, phenylamine was a benzene ring with an NH2 on it. Now, in this case, the lone pair of electrons on the nitrogen overlap with the pi bonding system in the benzene ring. And this means that the lone pair of electrons on the nitrogen atom actually is delocalized into the benzene ring, so it is less available to form coordinate bonds. So we say phenylamine is less basic or a weaker base than ammonia. So if we look at this question, which sequence shows these compounds in order of decreasing basicity? Decreasing basicity means I want to start with the more basic. Again, what did we say? An alkyl amine is a stronger base than ammonia, and ammonia is a stronger base than an aromatic amine. So, which of these is correct? That is the order present in C. When dilute hydrochloric acid is added to butyl amine and the solution is allowed to evaporate to dryness, a white solid forms. What is the formula of the white solid? What is he saying? I have butyl amine, so this is butyl amine. And I'm reacting it with dilute hydrochloric acid, and he's saying I get a white solid. So what is the white solid? The white solid is that butyl ammonium chloride that we get, which is in B. We do not get a chlorobutane. We do not get an amide, which is in C. We do not get an acid, which is in D. You just get the salt, which is the ammonium salt. The organic compound 4-aminophenol can behave as an acid and a base. So this is 4-aminophenol. He says it can behave as an acid and a base. What is formed when 4-aminophenol reacts with hydrochloric acid? Remember that the part that will react with the acid is the basic part. So it is the NH2 part. So the NH2, if you put it in acid, we said it forms the ammonium ion. So which of these is correct? The first one is correct. Remember, the part that is NH2, that is the base. So that is the part that will react with the acid and form ammonium salt. The part that has the OH, that will be the one that will act as an acid. Okay, how do we prepare amines? Well, one method of preparing amines is reaction of ammonia. Remember, we said amines are substituted ammonia or substituents of ammonia. Okay, if I react ammonia with halogenoalkanes, what comes out is an amine. So the halogenoalkanes will undergo, and this kind of reaction is nucleophilic substitution with ammonia. The ammonia replaces the Br. So if I'm starting, for example, with bromobutane, I end up with butyl amine. Remember, the other product is HBr. So this reaction, if he's saying the conditions are excess hot ethanolic ammonia. So this is ammonia in ethanol and hot, and I need the excess ammonia so that it can react with the HBr and prevent any further reaction between the HBr and the amine, which would continue to substitute the hydrogens on the nitrogens, so it would form mixtures of secondary and tertiary amine. So I stop at the butyl amine by removing the HBr as it is formed. What is the mechanism of this reaction? We said it's a nucleophilic substitution reaction. So if I have a halogenoalkane, the lone pair of electrons on the ammonia will attack the slightly positive carbon, and the electrons of the bonds will go to the slightly negative Br, and that forms my ammonium salt. Another molecule of ammonia will take that extra hydrogen to give me the amine. So this is nucleophilic substitution. What is an organic product of the reaction between ethylamine and chloroethane? So if I'm starting with ethylamine and I'm reacting it with a halogenoalkane, chloroethane, we said the lone pair of electrons on the nitrogen will attack the carbon, releasing the Cl, so you're adding that extra ethyl group on the nitrogen. So which of these is my product? Can you see that? It's a nitrogen with two ethyl groups, and this is an ammonium chloride salt. Okay, then another method of making amines is by reduction of nitriles. So nitriles are the ones that have a C triple bond N at the end. If I react this with lithium aluminium hydride in presence of dry ether, it will reduce the C triple bond N to CH2 and H2. So this changes the nitrile to the amine. Now, butyl nitrile is reduced to give butyl amine. Where do we get the butyl nitrile? Remember that to prepare the butyl nitrile, I need to react the halogenoalkane with potassium cyanide in ethanol and heat under reflux. So I'm starting with something that has 3 carbons. So that is bromo propane. Now, when I react it with the cyanide group, now it has 4 carbons, and now it is butyl nitrile, which can then be reduced using lithium aluminium hydride in dry ether to give the amine. So this question says, which amine could not be prepared by the reduction of a nitrile? So let's take a look. Which of these cannot start from C triple bond N? So if I look at A, yes, A can have C triple bond N, and then when it is reduced, it will give you that alkyl amine. What about C? Let's look at C first. C, yes, I can have this kind of compound, reduce it to get C. What about B? There is no way that I can start with a C triple bond N, because remember, carbons cannot have more than 4 bonds, so you cannot have the carbon of the C triple bond N attached to 2 alkyl groups. In D, you can prepare it from the nitrile. This question says amines may be prepared by reduction of nitriles. Identify the nitrile and the reducing agent used to prepare butyl amine. So he's trying to prepare butyl amine, and that means he's going to start with this nitrile, which we call butyl nitrile or butane nitrile. And this, we said, uses lithium aluminum hydride, or what they call lithium tetrahydroiodoaluminate, in presence of ether. Another method, and this is to make aromatic amines, I can start with nitrobenzene. Remember, the word aromatic means it has a benzene ring. So I want to make phenylamine. Phenylamine is made by reduction of nitrobenzene using what? Using tin in presence of concentrated HCl. Remember, we said if I want to change NO2 to NH2, I react it with tin in presence of concentrated HCl, then aqueous sodium hydroxide, and that gives me the phenylamine. This can then be separated from the reaction mixture by steam distillation. Okay, what kind of reactions do amines do? Well, amines can react with ethanol chloride or acid chlorides in general to form amides. So if I have ethyl amine, the lone pair of electrons on the nitrogen attacks the slightly positive carbonyl carbon. This forms in the end, it forms the amide. So this is how we make amides from amines. React with acid chloride. So this question says, explain how the structures of ethanol chloride and compound A enable them to react, forming that final product to ethanol amino benzoic. So let's look what is happening. This is starting with a benzene ring that has an amine group and an acid group. The acid group is not reacting here. What we're talking about is the amine group, the NH2, reacting with the acid chloride, the CH3COCl, to give that final product. So what is happening is the lone pair of electrons on the amine group attack the partially positive carbon atom on the carbonyl. Then the CCl bond breaks and electrons move to the Cl, so I form Cl minus and I end up with the aromatic amide group. Reaction of amines with copper-2 ions. Remember that we said copper-2 ions reacts with amines or with ammonia to form complex ions. So remember that copper-2 ions in solution is blue. If I start by adding drops of ammonia, then we end up with the blue precipitate in which 2 of the water ligands have been changed into OH, 2 OH groups. Then when we add excess ammonia, we said the blue precipitate dissolves to give a dark blue solution, and this is because the water ligands, some of them are exchanged with ammonia ligands. And remember that this dark blue solution is a complex that is octahedral in structure. We said if we have a transition metal complexed with 6 compounds or 6 ligands, then this is an octahedral structure. We also have reaction of aromatic amines with nitrous acid. And what is formed here is called the benzene diazonium ion. So if I have an aromatic amine, like phenyl amine here is an aromatic amine. If I react it, I want to react it with nitrous acid, but actually we don't add nitrous acid. What we add is sodium nitrite plus HCl. So the mixture of sodium nitrite with HCl, this is what we call nitrous acid. It changes the NH2 to benzene diazonium ion, in which we have a triple bond between two nitrogen atoms. Now, remember the conditions for this reaction. In order to form a benzene diazonium ion, first we react the aromatic amine with what? With sodium nitrite plus hydrochloric acid. Now, what is the temperature that should be used? Remember, the temperature has to be below 10 degrees Celsius. So we have to do this reaction in ice. This is because the diazonium salt that is formed is unstable. If we put it at a higher temperature, it will decompose easily to give nitrogen gas. Then the benzene diazonium ion can go further and do what we call coupling reaction. So if I have the benzene diazonium ion, I react it with a phenol in alkaline solution. So this is phenol in sodium hydroxide. I end up with something that is an orange dye, and this is what we call an azo dye. So this is produced from reaction of benzene diazonium salt with phenol in alkaline conditions, and this type of reaction is called a coupling reaction. Now, what is happening here is that the positively charged diazonium ion acts as an electrophile. It substitutes into the benzene ring of the phenol in the 4 position. So if you look at the product, the OH is on one end of the benzene ring, and the nitrogen compound, the azo benzene, is on carbon number 4. The delocalized pi bonding system extends between the 2 benzene rings through the N double bond N group. All of this makes the azo dye very stable. You have a pi bonding delocalized over the 2 benzene rings and the N double bond N, which acts as a bridge. This makes the azo dye very stable. Other brightly colored dyes may be prepared if we use other aryl compounds instead of phenol. So we can have this kind of reaction, and also the product is an azo dye. This question says, a reaction scheme for the preparation of an azo dye from phenylamine is shown. What are the reagents and conditions for step 1? What is he doing in step 1? He's changing the amine to diazonium salt. The N2 plus, that's the diazonium salt. So how did we say we should do that? We said we should react it with sodium nitrite and HCl. And again, remember that the temperature has to be below 10 degrees Celsius. Which reagent and condition are used for step 2? This was step 2. Can you see step 2? In step 2, what he did was he reacted the diazonium salt with something to get that product. So he needs to react it with what? He needs to react it with this kind of compound. If you look at the products that he drew, this is the kind of compound that I need to react with the diazonium salt, and we said this has to be in alkaline conditions. This is the reactions that we called coupling reaction. Okay, what are amides? You should know that amides contain this kind of group, a carbonyl group with an amine attached to it. So this is an amide. How do we make amides? Amides are made from amines reacting with acid chlorides. Remember that one of the reactions of amines, we said we can react it, for example, with ethyl chloride. This will give the amide. So if we react ethyl chloride with ethyl amine, then this is the kind of product that I get. So we always get the amide plus HCl. And this reaction releases the HCl in form of white fumes. So when this reaction happens, the HCl is in form of white fumes. What kind of reactions do amides do? You have to know that amides are neutral. Remember that we said amines are basic, but amides are neutral. So this CONH group can be hydrolyzed with an acid or a base. So if we add an acid to this compound, what I end up with is an acidic product. So I divide or I break up the amide bond to form an acid and the amine in the form of an ammonium salt. But if I hydrolyze it, break it up in presence of an alkali, then I don't get the acid, I get the sodium salt of the acid. Can you see that? Plus the amine part. Can we see this? Okay, we said, remember, how do we reduce amides? We can reduce amides to form amine. So I can go back to amine by adding lithium aluminium hydride. This is a reduction to give the amine. What are amino acids? Remember that amino acids are the building block of proteins. They are compounds that contain both an amine group and a carboxylic acid group. So you can have the R that we're drawing here is the part that varies in different amino acids. If I have the simplest amino acid, which we call glycine, then R in this case is an H. Then I can put different kinds of R's, different kind of alkyl groups. This will make one amino acid different from the other. But all amino acids have a carbon that is attached to an acid and an amine, and then it is attached to some other group. You need to know that a solution of amino acids contains what we call a zwitterion. A zwitterion is something that has both positive and negative charges, so it can act both as an acid and as a base. And this is what we used to say about amphoteric compounds. So if I have an amino acid, it actually exists in this form, in which the hydrogen of the acid is removed and it is attached to the NH2, so that the NH2 is actually an NH3 plus group and the acid is actually a COO minus. This kind of compounds are referred to as zwitterions. This means that they are ionic, and this gives the amino acids strong intermolecular attraction forces. So you'll find that amino acids are actually crystalline solids which are soluble in water. This strong intermolecular ionic bonds cause the amino acids to have high melting point. So if we say, why is it that amino acids have high melting point? This is because they have strong ionic bonds between the molecules. So it's not just weak van der Waals forces or London dispersion forces, they have ionic bonds. The positive on one amino acid is attracted to the negative of the next amino acid, and this kind of attraction is strong electrostatic attraction between the positive and negative ions, and this needs a lot of energy to be broken. So amino acids have high melting points. Now, what if I put amino acids in acid or in base? you should know that amino acids can resist changes in pH when small amounts of acid or alkali are added to them. And we call that a buffer solution. If you remember, we said buffers, if you add a little bit of acid or a little bit of base, it does not really change its overall pH. This is because if I put the amino acid in acid, then the COO minus part of the zwitterion accepts H plus ion and forms the COOH. And I still have the NH3 plus. So overall, this is now a positively charged ion. But if I put alkali, then the ammonia, the ammonium positive part of the zwitterion donates the H plus to the hydroxide, and it returns back and becomes an amino group, and this leaves an overall negative charge. So remember that as a solution, the amino acids are zwitterions, positive and negative, positive on the nitrogen, negative on the acid group. But if you put it in acid, then overall it's a positive charge. If you put it in base, then overall it is a negative charge. And that means if you have this zwitterion, can you see this zwitterion in the middle? This is neutral. So if you were to measure its pH, it's about 7. Universal indicator paper will give you a green color. You put it in acid, then it forms a cation, and that is acidic with low pH. You put it in base, then it forms an anion, and that has a high pH. So let's look at this question. He's saying the structure of amino acid isoleucine is shown, and the first question here is, what is the systematic name of isoleucine? Remember that this is a derivative of carboxylic acid, so we're going to name it as if it is a carboxylic acid. How did we name carboxylic acids? The COOH is carbon number 1. Now I have a substituent on which carbon I have. On carbon number 2, I have an amino, and on carbon number 3, I have a methyl. So the name here is 2-amino, 3-methyl, and overall I have 5 carbons, so this is pentanoic acid. Can you see how we name amino acids? This question says phenylalanine is a naturally occurring amino acid found in meat, milk, and eggs. And he gives me the structure of phenylalanine. Complete the structure of the zwitterion of phenylalanine. If this was to form the zwitterion, we said, how do we form the zwitterion? We remove the H of the acid and we add it to the NH2, so now it's NH3 plus. This is the zwitterion. This question says alanine is an amino acid. Which structure best represents alanine at high pH? So the first question you're going to ask yourself is, high pH, acid or base? You should know high pH is a base. So which of these is the form that we have in a base? Of course, if you look at all of this, it's the one that has the acid in the form of COO minus that will form this as a base. So it is the amino group and the carboxylate ion. All of this will form a base that is something at a high pH. This question is about the amino acid serine. Which ion is most likely to form if serine is dissolved in sodium carbonate? Okay, the carbonate reacts with what? Reacts with acid. And we said if we have a carboxylic acid reacting with carbonate, it gives the sodium salt. How do I draw the sodium salt? That is the part that we have in D. So we have the NH2 remains as it is. You cannot change it to NH3 plus. It changes to NH3 plus only if I add acid. But here I'm adding sodium carbonate. So I'm going to form the sodium salt. That means I'm going to remove the H of the acid and put a minus so that it attaches to the Na plus. Serine has a high melting temperature in the region of 200 to 300 degrees Celsius. This high melting temperature is mainly due to the formation of what? Do you remember? We just said, why is it that amino acids have high melting points? We said they have high melting points because they have what kind of bonds? Ionic bonds. The positive of one amino acid is attracted to the negative end of the other amino acid. What is the structure of isoleucine in the solution of pH 2? So I'm going to put the amino acid in pH 2. You should know that pH 2 is what? It's acidic. So which structure do we get in presence of an acid? It is the one where we have the ammonia becomes NH3 plus and the acid is just as it is. Okay, you should realize we said this is the structure of an amino acid. So it's a carbon attached to a carboxylic acid group on one side, an amino group on the other, an H and an R group, which we said is the difference between one amino acid and the next. So amino acids in this case have a chiral center. Do you remember the meaning of chiral center? A chiral center is a carbon attached to 4 different groups. So amino acids have a chiral center, and since they have a chiral center, they can form optical isomers. And we said optical isomers are the ones that can rotate the plane of polarized light in opposite directions. Okay, then we need to talk about polymerization. Remember, polymers are large molecules made by joining many small molecules together. Now, the small molecules are called monomers. So monomers are small molecules that can be joined to many other small molecules to form a long chain unit. And remember that this process of joining small molecules to form a long chain, this is called polymerization. So, addition polymerization is one in which we start with alkenes. So in this case, my monomers are alkenes or unsaturated molecules having C double bond C, and we're joining many of these small molecules together to form a long chain. And we said this is called addition polymerization. So the polymers formed have strong covalent bonds. And because of that, they are non-biodegradable. They accumulate in dump sites. And if we try to burn them, they release harmful gases. So they're very inert. They don't break down. How do we draw a polymer starting from an alkene? Remember, if I want to draw the polymer of but1ene, what should we do? Look at the 2 carbons that have the double bond. Write it as a single bond. We put a bond before and bond after because we're going to join it to other small molecules. And then we're going to draw a bracket with an N to indicate that this part that we're drawing is actually repeated many, many, many times. And then I look at each carbon. So the carbon on the left is attached to what? It's attached to hydrogen and hydrogen. That's what I copy. The carbon on the right is attached to what? It's attached to hydrogen and all of that group. So attached to hydrogen and a group that has C2H5. And if I'm starting with but1ene, we said the polymer is poly, the same name. So the name of the polymer is polybut1ene. Do you remember this? We did this in the O-level and in the AS. How to draw polymer of propene? Again, look at the double bond, draw it as a single bond, a bond before and a bond after, and you bracket and then N. Now, the carbon on the left is attached to what? Hydrogen and hydrogen. The carbon on the right is attached to what? Hydrogen and CH3. Okay, remember how to draw that? Okay. What if I want to draw the polymer of vinyl chloride? Vinyl chloride is same as chloroethene. We draw it in the same way, so this is the polymer of vinyl chloride. Butene, in the same way we get polybutene. What if I'm starting with this compound? This compound is called ethanol. So it is ethene with an OH on it. We draw the polymer in just exactly the same way, and the polymer will be called poly, the same name, polyethanol. If I'm starting with propanamide, this is propanamide. So it has propene with an amide group. Again, we draw it in exactly the same way, and we get polypropanamide. So this question says the structure of crotonamide is shown. What is the repeat unit of the polymer formed from this monomer? So this is the monomer. We said when we're trying to draw the polymer, we look at where is the double bond. Change it into single bond, bonds before and bonds after. So which one is my polymer? That is the one in A. The other kind of polymerization was condensation polymerization. And in this case, I'm not starting with alkenes, I am starting with monomers that have active groups on both ends. For example, we said polyamide, I'm starting with a diamine and a diacid, so that when I join them together, I end up with a polyamide. This has an amide linkage, so this is a polyamide. And you should know that a synthetic polyamide is nylon. A natural polyamide is proteins. So if I want to draw the polymer from these two monomers, this is the polymer called nylon 6,6. This is made from a diamine and the diacid. So if I join them together, I end up with this polymer, and this is what we call nylon. You should remember that proteins are natural polyamides. So the proteins are formed when amino acid molecules react with each other in a condensation reaction. I have amino acids, each of them has one end amine, one end acid. So the acid of one will react with the amine of the other to form an amide linkage, or what we call a peptide linkage. And this is how we make proteins. We join many small amino acids together to form a long chain. So if he says draw the structure of the dipeptide formed from phenylalanine. So this is phenylalanine. If it's going to react with another one like itself, the word dipeptide means two of them are going to react. Proteins is actually a long chain of many of them reacting together. But a dipeptide are two molecules of this. So if I have two molecules of this and I join them, we said the amine of one will react with the acid of the other, so we get an amide linkage between the two. How many different amino acids form the repeat unit shown? Remember that each amide linkage, which one is the amide linkage? The one that has C double bond O attached to N. Each of them is joining between two monomers. So how many monomers do we have? How many amino acids? Can you see what I'm doing? Remember that some of these can be similar. So if he's saying how many different amino acids, then I can see that the red one on the left is the same as the red one on the right. So that's one type of amino acid. The blue on the left is the same as the blue on the right. So that's another amino acid. And then there are two different amino acids in the middle. So actually the total number of different amino acids is 4 different types of amino acids. Okay, the next question says, which type of compound cannot be a monomer in the formation of polyamides? We said if I want to make polyamides, what can I start with? I definitely cannot start with an amide. I can start with amino acids because we said amino acids, the acid of one will react with the amine of the other to form the peptide bond or the amide bond. I can also have diacyl chlorides because the diacyl chloride acts exactly like the diacids. The amine of the diamines will attack the carbonyl of the diacyl chlorides. So my monomers can be diacyl chlorides, they can be diamines, but they cannot be amines. This question says the repeat unit of a polymer is shown. This polymer could be what? Can it be a polypeptide or a polyamide or what? Well, let's take a look at this. You can see that this is the amide linkage. So this is the linkage between the two units that we are adding. Now, what are the two units? The two units are a diacid. So the green one, the one in the green box is the diacid reacting with a diamine. This forms a polyamide, but it's not a polypeptide. Remember that a polypeptide is one that is formed from two amino acids. My units are not amino acids. My units are diacid or diacyl chlorides and diamine. So that is a polyamide, but not a polypeptide. Again, which pair of monomers could react to form a condensation polymer? So which of these we said to form a condensation polymer? I should have one of them diamine and the other either diacid or diacyl chloride. I cannot have the one in D because the one in D says diacid with amides. We do not react the diacid with a diamide. So C would be the possible monomers. Okay, and that's the end of this chapter. I hope this was useful to you. Please share the video and thank you for listening.